Hello everyone and welcome to conditional probability. All right, today I hope you did well on your other ones. We're going to be learning about conditions and when they work and when they don't work and how to combine a few things. So you should have a conditional probability set and ready to go. All right, when you look here, given events A and B, conditional probability is the probability of the event B occurring knowing that A has already occurred. So when you look here, the notation is the probability of B given that A has happened. All right, so that's read the probability of B given that A has occurred. I ran out of room, sorry. I can't even read my own writing. I don't know how you're going to read it. There we go. I spelled it wrong. All right, now when you go through here, conditional probability formula is always the one we just wrote, PB given that A has happened, and it's the probability of A and B all over the probability of A. That formula to me has always been confusing. I'm going to show you how I do it and see if it kind of helps you out a little bit. All right, Mitchell drew a card from a standard deck of playing cards. What is the probability that he drew a queen given that the card was red? So when I think about this, a queen given that the card was red. Well, card was red, that means it's out of 13 because I always start with the given that, all right? Given that the card was red. Okay, out of my 13 cards, how many are queens? And the answer is 1. So you're done. All right, let's try yours. A number from 1 to 100 is randomly selected. What is the probability that is a perfect square given that it is an odd number? All right, I'm hoping you have your sheet in front of you that has all this on it because your notes should have been printed with that on the back. Hang on, I gotta find my sheet. I'm gonna pause this and look for it. Okay, we know that out of this in here we have 50 odd numbers. Okay, we know our perfect squares are 1 squared is 1, 4, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 64, 64 and 81. So this one's even, I'm sorry, even. So we have 1, 2, 3, 4, 5. One is not odd. No, 1, 2, 3, 4. So we got 5 out of 50, which means we have 1/10. All right, this one here I think is easiest with a Venn diagram. So let's draw this out and see if this will help us understand this one. Okay, there are 62 people that take a yoga class and 48 people that take spinning class at the gym. So I got yoga and we have spinning. 15 people that take yoga also take spinning. So I know I have 15 that intersect. All right. So out of 15, so if I have 62 that take yoga, 15 are here. That means there are 47 that take yoga that don't spin. And in my spinning class, there are 33 of them that take spinning that don't do yoga. 15 that do both. All right, now let's read our question. If a person from these groups is selected at random, find the probability that he or she takes yoga class if you know, so this is where you start, if you know that they take spinning class. So these are the groups that I care about, right? They have to take spinning first. So if I look at my spinning class, I have a total of 48 people. Out of those 48 people, I don't care about these anymore because they don't take spinning, so they don't count. 15 take yoga. So it's 15 out of 48, which reduces down to 5 out of 16. Okay, pause and try yours. So we have 30 students in Mrs. Smith's math class. 13 are athletes. So here we go. We have athletes. 9 are in band. Okay, so we have band kids. 9 of them are there. 3 of the athletes are also in band, so I have 3 that overlap here. So I have 3 athletes in band, so that means I have 10 that are not in band. And of my 9 band kids, I have 3 that are athletes, so 6 of them are not athletes. So here we go so far. We got our Venn diagram to this point. Now, if one student is chosen at random, oh, I got people outside here. I got 30 total students, right? So in the class itself, I have some that aren't athletes or in band. So if I look here, I got 19 students here. So 30 minus 19 would be I have 11 of them that are neither. Okay. If one student is chosen at random, find the probability that that student is in band if it is known that they are not an athlete. So this is tricky. They are not an athlete. So I'm going to take all my athletes out of the equation. So these guys are all gone. They don't count because they're not an athlete. So that means I have these 11 plus these 6 left. So I have 17 students that I'm looking at. So out of these 17 students, what I want to know? That the student is in band. So if that means they are in band, it's this section. So 6 out of 17 count. All right. I hope that helped. Okay, two-way frequency tables. I think these are kind of fun. Okay, the table shows the result of a poll of 50 randomly selected students who were asked what they prefer to watch, hockey or football. Find each preferable. Okay, I want to know. So here's the given that. So I care about the girls. So out of the girls, you're looking here, right here, because that's my given that, who prefer football. So that's 6. So the answer here is 6 out of, and then I have 22 total girls. 22 girls. Okay, pause and try yours. Okay, I'm going to erase this so you can maybe just highlight. I have hockey is who we care about now. Maybe I'm not going to highlight. Let's try it again. No? Okay. Not highlighting. All right, let's try it this way. Here we go. We have hockey now as my given that. So this is the section we care about. There are 26 people who like hockey. So out of my hockey, how many are boys? And I have 10. So it's 10 out of 26, which reduces down to 5 out of 13. All right, let's go here. I'm going to do the first one with you, and I want you to do 6 on your own. All right, we got 150 people. It says, a 7th grader who takes French. There is no given that. So it's just all of them. So we go the 7th grader who takes French, there's 25 of them. So that's 25 out of all of the students because we didn't separate it down. We didn't break it out. It's just a normal probability. This next one is the 8th grader who takes Spanish. So now I care about Spanish, which is these group right here. So we got to add it up. So that's 8, 68 of them. So we have 68 people who are taking Spanish. Out of these 68 people, who are 8th graders. So we go here. We have 68 total. 8th graders, there are 33 of them. See the given that? All right, let's see if you get yours. Just try this one. 6th graders is who we care about, so we add this group up here. So out of these, we have 42 6th graders. Out of this 42, 19 are taking French. 7th graders takes French. So now we care about the French. And when you add all those up, I think there's 82 of them. How many of them are 7th graders? And the answer is 25. Okay, pause and do yours. Okay, this one wasn't that. Did not have a given that. So it's everybody. Okay, we look at this poll, and I don't think they added up. So we got it up for us. So you add 28 and 56. You add that down. You add your 97, 19. You type all that in. There's a total of 200 students. So out of my 200, a junior that did not attend prom. Junior, no prom, 56. So I hope you got 56 out of 200 there. The next one did not attend prom and they were a senior. So now you're looking at this group here, a senior. So you added those up and you should have got, there's 116 of them. So we have 116 we're looking at because that's my seniors. Did not attend prom would have been 19. Did not attend prom. Okay, this one here's attend prom. So now you're going this way. You're adding these up. So 97 and 28 should have got 125. So we have 125 that did attend prom. Out of those, 28 were juniors. Did you do a good job? All right, next we're going to talk about a joint relative frequency, the values in each category divided by the total number. So basically changing these to percentages. Marginal relative frequency is found by the totaling each row and column. So let's go through and see if we can figure this out. We got our first class, our coach, and the number of bags they can take on. And we got to find our relative frequency. So when we go through here and we add all of these up, there's a total of 160. So to find the relative frequency, we just take 16 divided by 160. 52 divided by 160. And you do this to every single element in our chart. All right, so now if you divided all those by 160, you would have got a 0.1 here, 0.325 here. Okay, pause and do the rest. Okay, I hope your chart matches mine. You should have got these numbers right here in this section by dividing by 160. And then your total, you just add them up. So you took these two, you added them to equal here. You did the same here and the same here. This one actually comes from both your column and your row. So you added this column up right here, so all the way down, so all of these, and you should get 1, and you should add this row across and get 1. Sometimes you're only close, you're like 0.999 or something like that. That's okay, that's a rounding error, and we're all right with that. Okay, a coach class passenger that did not check any bags. There's no given that, so you just look at the table and read. So we go to coach class, no bags, it's just 0.1125. All right, to change that to a percentage, we move our decimal 2 places. So it's 11.25% did not check. So the next one, we go a first class passenger, given that they checked at least 1 bag. So first class, so we're at this. All right, the problem here was it said at least 1. So at least means 1 or 2. So I have to add those up. I have to take the 0.1 plus the 0.075, add that up, and we get 0.175, which is 17.5%. Pause and do yours. Checked 1 bag. So we're given that they checked 1 bag, so we're on this section right here. And I want to know that they're coach class, so that's just 0.375 out of my total of checked 1 bag, which was 0.45. Type that in your calculator. Should have got 0.83 repeating, or 83.3 or 1/3%. Okay, next one, first class. So I look at first class, that's 0.187. Okay, checked 2 bags, so first class 2 bags is 0.1. Do that division, 0.53 repeating, or whoops, I wrote that wrong. Or let's see if we can get in there, 53.3%. I hope you did well. All right, you lottery ball 1 out of 50. This is your homework. I hope you do well. Thank you for listening. Make sure you comment on your discussion board.